Everyone, very good afternoon and welcome to Kotlin Mumbai's March 2021 meetup. I hope everyone is doing good and thanks for joining us today. So before starting, let's introduce with the community. So we are open community for developers. Most important, we love Kotlin and Kotlin technologies. We organize monthly meetups and host talks. And we are fully offline since last year due to this pandemic situation. And yeah, let's meet our team. Here is Siddesh, Rishit, me and Chintan. To know more about our community, please visit kotlinmumbai.tech and our code of conduct is also there if you want to take a look. So and yeah, finally be good to each other. Now I will hand over this to Rishit for further conduction of the event.
Hi. Before we go any forward, we are using Slido today to seamlessly take questions. So you can just go to slido.com and enter the code 000, or we'll paste the link to this, a direct link to this in the chat too. So yeah, simply go ahead and add any questions you might have, and we'll relay them over to Sebastian at the end of his talk. So with that, let's finally come to the thing which we are all here for, diving into Kotlin JS with Sebastian. So Sebastian is a developer advocate at JetBrains for Kotlin JS and Compose for desktop. He's also an enthusiast when it comes to learning new programming languages and tools. In his teaching and coaching roles, he generates excitement for new paradigms and solutions, and instills in his students and teammates with the same sense of wonder for new technologies that he feels pretty cool. And he also enjoys himself in the interface role between developers and non-technical project managers or customers. And finally, he has, with a strong background and compelling social skills, he has led multiple teams to create successful projects too. And by the way, he also hosts a really cool show, Talking Kotlin. So if you haven't already seen it, just go ahead and see about Talking Kotlin right now and see some episodes of it. But with that, I leave it all up to Sebastian. Um, Please take the stage and feel free to present your screen.
All right, cool. Let's get this show on the road. All right, I think that's my slides again. So thank you so much for that wonderful introduction. That was lovely. I could not have described myself in a more flattering way. So really very much appreciated. I'm very excited to be here, folks, to be talking to all of you about Kotlin JS, because Kotlin JS, I think, is sometimes a bit of an overlooked target for Kotlin, but it's super exciting nonetheless, and I think it shows a lot of promise. So while this talk is called Diving into Kotlin JS, don't confuse it with a deep dive into the technology. We're not gonna look into what makes the internals tick or whatever, but I really want to give you folks a type of taste for the technology, and kind of get you maybe started, give you an appetite to say, okay, let's get into this tech, let's try it out ourselves, see if it makes sense for us. So yeah, without further ado, let's kind of get into this, and let's kind of start with this fun markety phrase, which I often see when people want to describe Kotlin, which is that Kotlin is a multi-platform, multi-paradigm programming language with an emphasis on conciseness. And I mean, I don't need to explain that to all of you. You're likely, if you're spending your Saturday afternoon, or in my case, morning, listening to a talk about Kotlin, I probably don't need to tell you what the language is, but I want to emphasize the part that might not be so familiar to you, and that is the multi-platform part. Now, you may have heard about that part in general before. It just describes the fact that we don't just have a backend for JVM for Kotlin, but we also have native, which allows you to run Kotlin on iOS or just generally devices that require native binaries. And the focus of today's talk, which is Kotlin for JavaScript. So let's see how we can marry these two technologies together. And I'm actually really fired up about this, because I think the JavaScript ecosystem and kind of the browser as a platform is one of the most impactful pieces of technology that we've seen in the recent decade, I would say. Because think about it, you can bring executable programs to people with just a single link. They don't have to download anything. They don't have to install anything. Like the moment they click your link or the moment they visit your page, their experience begins. And I think this is really, really powerful. So let's see how we can do this ourselves as well. And I start this exploration of the technology the same way I start any exploration of technology myself. And that is with wizards. Now, I think wizards are really important to kind of learn how to just get started with something, right? They are kind of the easiest entry point. In IntelliJ IDEA, if you have a recent Kotlin plugin installed, if you click on File, New Project, you actually have the Kotlin category, which it contains a bunch of different options, including JVM application, native application. But if you scroll down a little bit, you also see 4 interesting templates for projects, which, well, very nicely match the topic for today. And that's full stack web application, browser application, React application, and Node.js application. And now, without even knowing anything about the technology itself, just based on this information, like based on these 4 points, we can already kind of deduce a little bit the possibilities that Kotlin JS at least seems to give us. We know that Kotlin JS supports different targets, well, because React applications usually run in the browser, and Node.js applications, as the name implies, run on the Node.js environment. We can also deduce that Kotlin JS has support for important frameworks, such as React. That's why the template's in there. And we can also deduce that Kotlin JS somehow is integrated with the whole multi-platform story. If I can build a full stack web app, that means a backend server and a front end in Kotlin, that means that Kotlin JS is somewhere in the mix as well. And I think that already gives us kind of a nice idea starting out, just kind of figuring out what's possible. And I mean, that's pretty broad. Like I am pretty sure that a lot of folks are now like, I wonder if I can do X, or I wonder if I can do Y. And yeah, the answer is probably yes. But let's actually dive into what happens when we create one of these projects, actually any of these projects. And what you'll see is a very familiar structure. So your project that's going to be opened is going to have a Gradle build file, Gradle properties, settings, and just a bunch of pure Kotlin files. Now, as a Kotlin developer, this makes perfect sense. But as someone who has also worked with TypeScript before, or just with JavaScript or whatever, you might be thinking, hold up, there's some complexity missing here. Maybe I'm hiding it in the resources folder or something. And that complexity is the whole modern JavaScript ecosystem, because we have come very far from just a simple JavaScript file, like a JS file that you put into a website and then it executes the code and that's it. Nowadays, a modern JavaScript project uses some kind of bundler that performs post-processing steps on the code that you write. You have dependencies from the JavaScript the ecosystem. You have some kind of installation, and you manage your dependencies in in a file called package.json, for example. And this is kind of orthogonal to what we usually expect as Kotlin developers. And the great thing is that me as a Kotlin developer, I understand Gradle. Well, I'm not sure if anyone actually understands Gradle, but I have enough of a basic understanding that I can use Gradle on a regular basis. And the great thing is that the little elephant we can see here really is our ally in the context of Kotlin JS as well. We have a plugin for Gradle, which allows us to kind of take all the complexity we have on the right side and manage it from our Gradle file immediately. And the best thing about this is that it ships with very useful defaults. So in many cases, you don't even have to think about these parts at all. So if we look into our Gradle build file, depending on our project, we can see one of two plugins being used. That is either the JS plugin or the multiplatform plugin, but they're actually doing the same thing in this case. And both of these will automatically handle the web packing of your project. They will automatically provide a mechanism for using dependencies. And they will both automatically make sure that the dependencies you've specified are downloaded and executed and bundled correctly. So again, there is a lot of complexity under the hood, but starting out, you don't have to think about that. And the reason why I don't actually have a configuration snippet on this slide is because I wanted to really drive home the point that it doesn't matter if you're using the multi-platform or the JavaScript plugin. For either one, you can use the same DSL. And that is actually quite exciting again, because it means that when you have a project that is pure JavaScript and you're thinking, hey, I want to make this a full stack project, it's literally just switching out the plugin. The DSL stays the same. Your configuration all stays the same. You switch out the plugin, and you can just add another target, which I think is personally quite neat. And as I said, kind of all the complexity of this whole bundling installation stuff gets abstracted in a way that feels very natural to a Kotlin developer. So if we want to install a package from npm, we'll see how to use it from Kotlin in a little bit. We just specify it as implementation, and then we say npm. We specify the package and the version number. And I think this is really nice because it really helps you think about the JavaScript things in terms of Kotlin or the Kotlin ecosystem. And of course, we have a bunch of more advanced configuration options in there as well. You can find information about those in the documentation, which kind of helps you kick things off. But again, there might not even be a case where you need to adjust them because the defaults actually work very well. So I think Kotlin JS is a really exciting target, especially in the context of multi-platform, because just like sharing between Android and iOS, for example, with multi-platform, sharing between your JVM backend and the frontend, the JavaScript frontend, it's all about sharing, and that is not only your business logic, but it also means your knowledge. If you like writing Kotlin, you probably want to write it everywhere. You don't want to start with multiple dialects of different languages that behave slightly different. But of course, it is also the option to make sure that the models your backend spews out can be consumed properly because they're the same version in your front end. And of course, there's the added benefit of this two-way ecosystem access, where your Kotlin applications want to and should be able to use JavaScript frameworks, for example, and vice versa, to really make the most use of the underlying platform. And of course, the other good thing is that all the tools, as you've seen, they just keep working. Like if you look at your code completion, if you look at DSLs, if you look at a bunch of libraries, which we're going to look at in a little bit, you'll see that the same mechanisms apply on the JavaScript platform as they apply on the JVM, for example. So let's actually dive into a little bit more specific use case, not too deeply, but again, I kind of want to just show you this. And that is building front ends with Kotlin JS. Now, there's a bunch of different ways you can do this. The classical example, I would say, is using React. So if you've done web development beforehand, you are already probably familiar with React, so this shouldn't be too new to you. If you haven't done anything with React and you look at this code, you might recognize a certain pattern from a different framework, which has gotten very popular recently in the Android world. I'll solve which framework that is in just a second. But looking at this, it's very clear that we have a kind of declarative API for specifying our user interfaces. So I've used React's hook syntax here, so I can fit a whole component actually on the page. Looking at it, we can see that we have some kind of component which has a state, which is a number, and then we have we describe a button which, if we click it, increments the counter. And yeah, we also put the number of the counter on the actual button. And what we get here is, of course, a button that when we click it a bunch of times in the browser, we see it counting up. Now, again, I don't want to dive too deeply into this. We have a wonderful tutorial called Building Web Applications with React and Kotlin JS on play.kotlinlang.org. So check that out if you want to get like a deeper understanding of this. But just generally know that this is possible. Now, one thing that I want to draw your attention to is that there's this weird button and then a code block. We'll look at that in just a second. So the folks of you who are staying up to date with Android may have recognized this that a very similar pattern has emerged recently with Jetpack Compose, which is also kind of a declarative UI framework. And you will actually, so the good news is if you want to try Kotlin JS with React for the time being, you can transfer a lot of the knowledge that you have from other declarative frameworks. So if you have Jetpack Compose knowledge, you might want to check out Tiger Oak's React to Jetpack Compose dictionary. I have to admit, for me, it was the other way around. I was first a React developer and then had to learn the vocabulary for Jetpack Compose. But 100%, if you know what you want to do in Jetpack Compose in regards to how to handle state, how to do memoization, all these kind of things, you can probably also just use it in the reverse direction and bring some of your knowledge in the context of Kotlin into the web browser. Now, yeah, I said for a moment there, note this weird button with a code block. And what we actually saw here is some type-safe HTML. Well, a very short snippet of it. I've added a bit of a bigger example on this slide, and I think this is actually quite exciting because it's the first time that you can kind of write HTML code or describe the layout of your page and enjoy the full compiler support of the Kotlin compiler while writing this markup. So if you have a typo, for example, or if you're trying to assign an href instead of an href and you just make a small mistake, it's going to tell you, and you don't have to dive through your actual rendered markup to find out these things. So yeah, the cool thing with Kotlin React and any other projects using the Kotlin X HTML DSL is that you really just express all your thoughts in Kotlin code. Again, this is kind of the motto of just write Kotlin, right? How does this work under the hood? You're probably familiar with the concept of DSLs by now because it's one of those really big topics that always gets brought up in the context of Kotlin. But just as a small refresher, there's no like compiler generation magic going on. It's really just combining the concepts of lambdas with receivers and kind of all these builder functions that we have so nicely in Kotlin to express our markup, our DOM tree. And this is really nice because, again, this is intended and supported. So it's not a hack that is specific for Kotlin JS or something like this. If you type this out, you're going to get code completion. The IDE is going to understand what you want to do. And the fact that it's pure Kotlin code also means that you can use constructs like a for each if you have a list. And in this case, so if we have an unordered list and we have list items, and we just generate 3 of them, and that's going to generate exactly the kind of markup that we would expect. So Kotlin X HTML really takes care of us for in this regard. Okay, back to React for a moment. Now, writing React in pure Kotlin is nice and well. We've seen that. We have this option that we can just define a function in a couple of lines, and that's going to work well. But one of the big reasons why people enjoy React so much is that they precisely don't have to build everything by themselves. There's a huge community on NPM that provides ready-made components for the React ecosystem. And it would, of course, be a shame to miss out on those just because we want to write it in our favorite language. Now, fear not. We actually have a way of consuming the React ecosystem and, in fact, the JS ecosystem as a whole as well. And that is through the use of so-called external declarations. Now, looking at this might look a little bit scary because I put all of it on the slide at the same time, but we'll go through it kind of line by line and understand what's going on. So again, as I alluded to beforehand, Gradle, the elephant, is our friend. If we want to use, for example, a component that is a YouTube player, we can just add to our build file, I want to use the component React YouTube Lite. That's going to be downloaded, going to be added to our compilation, just as we would expect. Then we somehow need to tell the Kotlin compiler about what we're expecting from this package, because we kind of need to bridge the gap between the dynamic world of JavaScript and the statically typed world of Kotlin. So we give this we do this little spell where we tell it, okay, we have a JavaScript module called React YouTube Lite, and this is going to give us an RClass, so a React component with properties called React YouTube props. And at the end of the day, we're really just telling Kotlin, okay, here is a React component which we can instantiate with a URL, and then we use it like any other URL. So there is a little bit of mechanics involved in using these packages. So it's not as easy as just importing them and praying that everything will work. You need to do a little bit of work around it, but once you've done this once, you can use it permanently, and that'll be fine. So, in fact, this is of course not limited just to React stuff. I've kind of shown this example beforehand with the camel case example, which is just a small string modification library, where once again, if you want to use it, it's not much more work than adding it to your dependencies and adding the definition and telling the Kotlin compiler, okay, this package exposes a function called camel case, which we are allowed to call from Kotlin. And once it knows that, it can verify that a call to camel case, which takes a string and returns a string, is going to work fine. Again, a little bit of mechanics, but honestly, nothing to write home about. So this is all nice and well, but we also, of course, have to think about the general developer experience, right? Because usually, especially when we're just starting out with the technology, we have very short iteration cycles because we don't understand what's going on, and that's perfectly fine. for example, we change a few lines of code and we want to see how it looks differently. And the good thing is that once again we have tooling support for this called continuous build execution. And once again, we are Kotlin developers and we have embraced Gradle. So if we run our application with the Gradle with the continuous flag, which is, by the way, a pretty difficult word to spell. That's an continue. Make sure you don't mistype that one, otherwise it's not going to work. Then Gradle is going to watch your project, and when you make a small change, so if I type everyone and I save the file, it's going to immediately recompile and it's going to show me the updated sources. So this is similar to live reload or auto reload in other projects. Yeah, so what have we seen here? We know that we can write React applications with Kotlin. In fact, what I kind of omitted here was that this is powered by an official library that we built at JetBrains called Kotlin React, which you can find in the Kotlin wrappers repository on GitHub. This also includes a bunch of other wrappers, for example, for styled components, for React router. So if you're okay with taking an opinionated approach and kind of going with the defaults in the React universe, then you have already kind of out of the box these wrappers that we maintain at JetBrains. Then there's also a bunch of wrappers that are already ready-made from the community. For example, there's Merwick, which is the material UI framework usable from Kotlin. There's UIKit and Design, which are in the Kotlin JS wrappers library. And again, if you use those, you don't have to write the magical spells we saw in the previous slides yourself. But of course, if you want to do something a bit more funky yourself, then you can always write these wrappers. It might take a little while to get them right, but again, the payoff is being able to write Kotlin instead of JavaScript, which, yeah, I think that's always worth it. Or of course, you can go a different route. I mean, who's to say that you need to use a framework from the JavaScript ecosystem at all? There are actually a number of frameworks that are being built which are Kotlin first. So they allow you to write web applications kind of without ever leaving the comfort of all of Kotlin. And this is especially nice because it means that these frameworks, opposed to if you're just using something from JavaScript, really make use of all the APIs that Kotlin has to offer. Because we're not working with some kind of subset of Kotlin here when we start doing Kotlin JS, we're still working with the full language. One example, which is maybe kind of a bit out there, is Corgi or Corhe, which is the multi-platform game. It's a multi-platform game engine, and that also allows you to run things directly in the browser. So again, it's a bit different, right, from React, because it's not as commonplace to build a game maybe, but it allows you to run things in the browser as well. If you're looking for something like D3, there is Data to Viz, which kind of takes the approach of D3 of kind of like data-driven documents and implements them in Kotlin multi-platform and also targets JS. But there's also these alternatives to existing like general purpose web frameworks. One of the examples is Kvision, which is kind of an object-oriented framework for building front ends with Kotlin JS. And even as you can see, the tagline says you build modern web applications with the full power of the Kotlin language, which I think is once again very exciting because it means that you don't have to fiddle around with any kind of wrappers. You're really just writing Kotlin, and you don't really have to think about how it compiles. And lastly, there's also Fritz 2, which is kind of the new kid on the block. It's been out for a couple of months, and it really focuses on building reactive applications using coroutines and flow APIs. So if that's a hype topic that interests you, maybe give Fritz2 a look. And I highlighted coroutines and flow APIs here because it's actually the perfect segue to the next topic and the next part that I want to drive home. And that is that if you use Kotlin on JavaScript, that also means that you inherit all the superpowers that Kotlin gives you while writing stuff for the browser. Specifically, that means that you can use all the official libraries which support multi-platform, for example, for testing, for concurrency, and for networking. Now, if these things are like when they're designed with these common abstractions that are just pure Kotlin instead of wrapping a Java library, that means you can literally just import them from Gradle and you can start using them immediately. So if you have some knowledge about these frameworks, these APIs, whatever, if they're multi-platform, again, you can just use them from the JavaScript target as well. One example for this is Kotlin X coroutines. There's really not that much to say here because it just works. They work on JavaScript as well. And I think it's actually very, very interesting on JavaScript specifically, because usually JS apps suffer from something called callback hell, or well, maybe sometimes they can. So what's callback hell? Callback hell, or this kind of fallen pyramid scheme, is when you have one callback and then you say, okay, and after this callback, call something else, and then after this callback, call something else. Or you have to somehow chain things with then, and you get this really hard to visualize control flow. And I mean, Kotlin X coroutines generally just try to get rid of this problem on all platforms, but on JavaScript, I feel like it's specifically impactful because we actually allow you to wrap these promises that you get from the JavaScript ecosystem into regular suspend functions. And you can just say, okay, if I have a promise, I'm just going to await it. And again, your knowledge is just going to transfer. Now, you might actually wonder, how does Kotlin know that what I'm getting back is a promise? Aren't we in a dynamically typed language? And you would be right to ask this. We're going to get back to that in just a minute. One small disclaimer, though. I know that people really love coroutines because they say, all right, let's start 1 million processes and let's run all of them at the same time. The one thing you have to keep in mind, it's still all just based on the event loop, right? So JavaScript is by nature, it is single-threaded. So if you're doing a lot of I/O tasks, that's perfectly fine. Go for it. Start 1 million of them. Your users are gonna love you. But if you're doing CPU-bound stuff, just using coroutines is not going to suddenly spawn another thread, or is going to allow you to do CPU-intensive work off the main thread. You're still going to have to do some kind of web worker magic, for example, to do that. Another thing that I want to kind of shout out, if you are just getting started, is Ktor clients. Now, you might know Ktor as this great server-side framework, or well, just a framework, but it allows you to, it actually has a second component. And the second component is Ktor clients. It's a little bit, I wouldn't say it's hidden in the documentation, but you gotta find the right little notch that says client to find it. And this is actually something to take note of, even if you're not taking away anything from Kotlin JS. It's generally, if you're doing multi-platform and you're doing HTTP, which includes Android, you probably want to use Ktor clients for this kind of stuff because it gives you this common abstraction to do really simple HTTP calls. And yeah, So if you're using OKHTTP, for example, maybe give Ktor a look and see if you can find the even more Kotlin native version of making HTTP calls interesting. And of course, these also work on Kotlin JS. So again, you don't really have to study, I don't know, the fetch API, which might not even exist in a certain context. You can just use Ktor clients, and it makes sure that you can write a line like client.get. You do an endpoint, you return a string. Just like that, works with coroutines, all good. In a similar fashion, a topic that needs a little bit of addressing is serialization. And serialization generally just is the question, how do I turn the stuff you see on the right, this JSON, into the stuff you see on the left, which is just a data class from Kotlin. Now, trivially, if you think about it, in JavaScript, you probably wouldn't need this because you're like, hey, this is JSON, right? It's the JavaScript object notation. But again, we are using Kotlin, so we have to make sure that this kind of stuff works properly. But fear not, this is actually quite easy to do with Kotlin X serialization with almost no runtime overhead. We just annotate our class with serializable, and then we get these wonderful functions called encode to string and decode from string. And again, there's really nothing funky going on under the hood here. It just allows you to do this conversion very nicely and without really having to think about a lot of the things. And again, this is actually also multi-platform. So if you are an Android developer once more, maybe give Kotlin X serialization a look, because that might be interesting for you just generally as well. And then, of course, we can combine the three things we just saw. We can combine coroutines together with serialization, together with Ktor clients, and we get this wonderful snippet where we create an HTTP client. We tell it that it should use Kotlin X serialization. We define our data class, and then within a single line of code, we get a type-safe return of the actual Kotlin object immediately. So this is something that I'm personally really excited about, because it really just kind of allows me to only think in terms of my Kotlin objects. I don't really have to think about, again, kind of the JavaScript world so much. I can really just focus on the part that I love so much. In the very beginning, we also saw that there was also a target that wasn't the browser. That was Node.js. And I just wanted to very quickly kind of give a shout out to this as well. I think it's probably not as much of a focus for some of you folks, but still, I just want to shout it out. We have currently in the incubator an API for Node.js, which allows you to kind of use the Node.js standard library, quote unquote, directly from Kotlin code without having to use any kind of wrappers or something yourself. So you can get that from GitHub, for example. And if you're now asking yourself, you're scratching your head, you're saying, well, why would I want to use Kotlin for Node.js? I think my connection just died for a second, so I hope that we're back. I'm just gonna continue, and someone's gonna stop me if that wasn't the case. So try to be a bit creative and think of a topic, for example, serverless, where you really need to optimize for your application startup. JVM, existing, well-maintained, but still kind of heavy in when it comes to startup times. JavaScript, very fast, really gets going quite quickly. But in the context of Kotlin JS, maybe still a bit on the fresher side with the library being in the incubator still. But these kind of specific APIs actually give the answer to the question which I raised beforehand. How does Kotlin actually know what kind of returns we get from functions from the browser, for example? And the answer for this is just all the APIs from your browser that a modern browser exposes. They're all standardized by the W3C. And we kind of take these definitions that are specific to modern browsers, and we generate Kotlin wrappers for those as well. And these are kind of the browser standard library which you can use from your Kotlin code directly. Now, why is this so interesting? Specifically, this is nice because it means that you're not working with something that, I don't know, some developer at JetBrains thought of. Instead, you can look at the official documentation. For example, I don't know, if you're drawing on a canvas, which we'll do in just a second, you can just look at the MDN, at the Mozilla Developer Network, and you can look at the HTML canvas element documentation, and the methods you're going to see there, they're going to be pretty much the same that you will see in your Kotlin JS code. So again, there's not really that much of a layer of abstraction between the two. And we tried our very best to make all of these APIs statically typed by default, but JavaScript can be kind of funky at some points with what kind of parameters it accepts, for example. In those situations, we have something called dynamic as a fallback. So this means that you can still use those APIs, but the type checker, the compiler is going to be like, I'm out. You probably know what you're doing. I can't check this. That's specific to the JavaScript target and is probably best used only kind of as a fallback. You can find more of that in the documentation as well. So how do you actually approach getting started with Kotlin JS? And I have a very simple mantra for this, and that is that to learn means to build. You can listen to me all day, and it might give you some kind of understanding of what's going on. It hopefully gives you a taste for the technology, but it's not going to replace you actually sitting down, opening a project, and building something with Kotlin JS. So I did the very same thing. For example, I really love kind of prototyping visual examples. They really help me. And the canvas element, which I kind of showed, or the documentation, which I kind of peeked at a couple of slides ago, is a great example for making these visualizations, right? So in just 15 lines of code, we can write something which gives us a little bit of a graphic representation. So, and as you can see, if you've written JavaScript beforehand, this code might look similar to you. If you've written TypeScript beforehand, and if you've written Kotlin beforehand, this might also not look too crazy to you. So let's kind of go through it. We use getElementById to just grab ourselves a canvas which is already in our HTML. We cast it as a canvas element. We get the context, and then we use this fancy with function, which is a helper function from Kotlin to kind of change your receiver. We just draw 30 rectangles of different colors. And yeah, the good thing is that at all points I get support from my IDE, so I'm never just guessing what I'm doing. I always have I'm never alone, so to say. And then you can kind of expand on this kind of stuff. One of my favorites is this small physics simulation, which I built, which is like 160 lines of code, which just simulates a bunch of circles bouncing around against static objects and just kind of hopping around. And it really helped me understand kind of the physics and help me debug some of these things, kind of brush up on some of the linear algebra, which I already forgot since I last visited a university. But the fact that this is just 160 lines in Kotlin code, and it wasn't any black magic, that's really just the math, made me kind of very happy and allowed me to really kind of experiment using a language that I love, but a platform that I don't have so much domain knowledge in. And of course, from there, it's always great to build toy projects. One of the examples that we had was I somehow convinced my team members that we should participate in a 48-hour hackathon and build a React application with Kotlin JS, which allows you to kind of run questions to an audience that are connected via the phone, and kind of do a quiz with audience participation. And again, this was kind of 48 hours, but it was really powerful being able, like all of us being Kotlin developers, it meant that people didn't have to completely relearn a different language. They didn't have to get all the intricacies of how do I shuffle an array in JavaScript. That is actually non-trivial. They could just use the same things, and people could hop between front-end and back-end development and really kind of share their knowledge and kind of work on all parts of the system, which is also why we actually won a prize. So quite excited about this. And it, of course, also goes beyond toy examples. We at JetBrains are huge proponents of dog fooding. So using our own products and using our own technologies. And the latest one, which also uses Kotlin JS, is JetBrains Space. It's our integrated team environment. So that combines everything from chats to repositories to your team directory, to your calendar, all of this. And the main entry point for this product is actually its web interface, which is written in pure Kotlin JS as well. So we've had a great experience with it, again, because we were able to share a lot of knowledge between front-end and back-end developers. Might be interesting to check out a little bit more about this as well. There's a great talk by Maxim Mazin called Kotlin in Space. You can check this one out if you are interested in getting a little bit more information specifically about also the JavaScript part, how we do like remote procedure calls, all of this. I think it's very exciting, and I think it also shows our commitment to the technology. So if you were on the fence about maybe they're not gonna support this for much longer, or maybe something else is gonna win out over it, we are committed to this technology. We are excited about it, and we love the fact that the community is also growing so much. So I want to kind of wrap up with talking a little bit about the future of Kotlin JS, because whether you know it or not, we are currently in a quite exciting time for Kotlin, for the Kotlin JS target, because we're reimagining and rebuilding the compiler for Kotlin JS. And the new version is going to be based on something called IR, or intermediate representation. Now, I won't bore you with the technical details of what's happening there. Just know that Kotlin JS IR is the clear path forward for Kotlin JS. It's currently in alpha, which means that there are some incompatibilities and there might be some rough edges, but we're working really hard to make this the new default, and that's about to arrive hopefully sooner rather than later. So why should you care? Because we have a bunch of features in the new compiler, which is gonna make Kotlin JS fly even faster and hopefully even higher. So one of the examples for this is TypeScript definition generation. So think about this. If you have a full stack application and you have JavaScript somewhere in your stack or TypeScript somewhere in your stack, you probably want to call your Kotlin libraries from TypeScript, but you don't want to write those definitions yourself. You just want to be able to interoperate directly. And with the new IR compiler, we are currently prototyping functionality to automatically generate TypeScript definitions for everything that you export from Kotlin JS. It's in preview, but you can actually already try it if you turn on the IR compiler for your project. How to do that, by the way, ideally you go to the documentation page and you look at the installation snippet. It's literally just changing a single line in your Gradle file. So what does that look like? If I have a class called Kotlin Greeter, and that has a function called greet, or if I have a top-level function called farewell in this case, and I mark them with JS export, that means that you will see this definition from JavaScript as well. So in the bottom, you can see kind of the TypeScript definition for the Kotlin Greeter class, which has been automatically generated, as well as the farewell function, which also has been automatically generated. And now compare this to the secret greeting, which in this case we're like, okay, the secret greeting we only want to have cool people call. We only want to have people who write Kotlin code be able to call. So this one, as you can see, that's not exported. We think this is going to make it really, hopefully, a lot easier for people to abstract away some of their business logic and still write some of their front-end code with JavaScript and TypeScript. Because the moment you have these declarations, if you use WebStorm or any other fully fledged web IDE, your whole Kotlin code is going to look just like any other JavaScript module that you import from npm. And I think that's specifically exciting if you're not building a new project and you have the luxury of choosing Kotlin JS to write everything. But if you are in a situation where you are already building a big project and you just kind of want to rip out common parts, put them into maybe a Kotlin multi-platform project. We're also working on code splitting and incremental compilation. This is something that we've heard about quite a lot. Really what this boils down to is we want to be able to compile your Kotlin JS applications quickly, so that kind of your iteration cycles are as short as possible. So from the time you make a code change to the time you see the change in your local browser should be as little time as possible, where this is helping. And code splitting, of course, can help with reducing your application, your initial startup time by kind of deferring later parts of your application to be loaded at a later point. And of course, something that web developers are absolutely enamored with is file size. We are trying our hardest to make Kotlin JS applications as small as your regular JavaScript applications. So with an example application from that we're building inside JetBrains, where it was beforehand like 3.9 megabytes just after the direct compilation, together with the IR backend and bundling, dead code elimination, which almost cuts the size in half, and then zipping, we're turning those 3.9 megabytes into 40 kilobytes just by getting rid of all the stuff that we don't need. And this is again something that we are very much committed to improving even further. And yeah, so I'm quite excited about the future of Kotlin JS. It very much remains bright, and I hope that we can get some of you folks on board as well with this technology, because especially now in a time where we are rewriting the compiler, it's important that we get feedback from the community, that we have people trying it out, showing us the rough edges, and just giving us feedback. So yeah, that's also kind of my call to action at the end of this talk. If you want to, if you're excited about it, give Kotlin JS a try. There are a number of different ways of how you can do that, of course. As I mentioned sometime a couple dozen minutes ago, we have some tutorials on play.kotlinlang.org about building applications with React and Kotlin JS, building full stack applications with Kotlin multi-platform, and we're also working on more materials all the time. And of course, there are the frameworks that I've shown beforehand, from Korga, the game engine, to Kvision, to Fritz 2. All of them have their own documentation and kind of learning paths, which make it really easy and nice to kind of get started with. And those folks are also very, very helpful. So if you want to get in touch with any of these folks, I would suggest joining the Kotlin Lang Slack if you haven't yet. You can find that under kotlin.in/Slack. And yeah, that's pretty much it from me. All I want to say is try some Kotlin JS and let's stay in touch. Feel free to reach out on Twitter, follow me on GitHub, or if you have any kind of proposals or really want me to see something, you can also always send me an email. Cool. Then thanks a lot, and I'm ready to take some questions if there are any.
Thank you, Sebastian, so much for this wonderful talk. It was really interesting for me, as in being an Android developer. I'm very excited to try my hands on with Kotlin JS for, like even making my simple portfolio website. So I will be definitely giving that a try. So yeah, we do have a few questions from the participants.
Mm-hmm.
So we can, attend them. Okay, so first question is, can I start web development directly with Kotlin JS or go with JS+React, then return to Kotlin post it? I am an Android developer.
Okay, so this is a good question. That kind of depends on how much knowledge you already have for like declarative frameworks. Like if you've never touched a declarative framework like Compose, for example, it's probably gonna be a bit harder. But I'll have to say I might be a bit of a special case, but I actually learned React with Kotlin JS. Now, spoiler alert, this was probably not as easy as just going for React and JavaScript first, but it's definitely possible. Again, if you are not so familiar with React or you don't want to bind yourself to React, check out one of the frameworks which I've shown, like Fritz2 or Kvision, because those are really like they take everything that you know and love as a Kotlin developer and just allow you to kind of bring it to the web without having to think about like, oh, what's the React terminology, what kind of framework do I use, like all these kind of things. So maybe go for kind of a React-based framework. Oh, and of course you need to know a little bit of basics about like HTML and stuff. There's just no way around that because that's just the platform.
Yeah, excited. Okay. Is there any plans to support JetBrains Compose UI development to get the Kotlin JS for web development?
That's a great question. We're experimenting with it. So I don't have an ETA for you. But I think Compose. I personally think Compose has huge potential being multi-platform, and that includes JavaScript. We're experimenting with it. I don't want to make a strong commitment to this, but if you actually looked at the JetBrains careers page a couple of weeks back, you may have seen that we were hiring someone to evaluate this technology for us.
That's good. Okay. Is it possible to generate source maps for Kotlin JS Code to possibly make it easier to develop?
Yeah. Okay. So in the current compiler, we actually do have source map support. So you do have source maps in the browser, for example, and if you run unit tests, it's going to show you the correct stack trace. It's not just going to show you some mangled JavaScript. And yeah, so you can use, for example, the Chrome debugger, which works quite well. As of now, the IR backend currently doesn't have source maps, but yeah, that's also going to come at some point.
Okay. Yeah. So can we make cross-platform application with Kotlin, which runs on Java and also on iOS and Android?
I mean, this is a bit of a broad question, and I think I can give a bit of a broad answer to that. The answer is yes, but it's comma but, and the big but with Kotlin multi-platform generally is how much or how do you define cross-platform? If the question is can I share literally the same code without any modifications across all platforms? The answer is no. But if you want to encapsulate your business logic for your application, if you want to encapsulate, for example, as I said beforehand, networking or data models, you can turn all of those into a single Kotlin multi-platform kind of module, and then you can write a Compose UI for this. If you're on Android, you can write a Swift UI for it. If you're on iOS, and you can write a React or a Fritz2 or a Kvision UI for this if you are on the web. So you can share code, but it's not as easy as pressing a single button. That's also currently not what we're trying to support.
Yeah, so that's like we can share most of our business logic and
Yeah.
UI can do it.
Mm-hmm.
How does Kotlin JS compare to another multi-platform framework like Flutter Web?
I think this is a bit of a difficult question, because I think Kotlin JS is more of just a technology or a language target, whereas Flutter Web is this highly opinionated way of this is how you can build an application that also runs on the web. So I would encourage you to look at Kotlin JS in its current standpoint as a dialect of JavaScript more than a specific framework imposing specific constraints on you. So it might be a little bit harder to share code like one-to-one, but it also means that the application that you're going to write is going to work with the regular DOM. It's going to be accessible, and it's going to be like web native, quote unquote, and not just kind of a recompilation of your local user interface, which might not feel like a real web app.
So next question is, does Kotlin JS and multi-platform application, that is the full stack, support raw CSS file, or we have to use Kotlin CSS DSL itself?
Okay, so we have the answers both is possible. We have a Kotlin X CSS DSL, which allows you to write type-safe CSS, which I think is quite exciting actually. But you can also just put a CSS file in the resources folder of your project. And by default, if you create a new project, it already has Webpack pre-configured with CSS support. So there's literally just in your Gradle file, there's a flag called enable CSS support equals true, or CSS support equals true. And at that point, it's just going to read that CSS file as well if you need it. You can just embed it in your HTML. It's just going to work. And if it doesn't work, by the way, please let me know on the Kotlin Lang Slack. Yeah.
Sure. So are there any limitations where targeting JS on uses of Kotlin's language feature either as a part of standard library or coroutines? For example, using flows?
No. So the exciting thing is actually the Fritz2, which I showed, it heavily relies on Kotlin flows as kind of an architectural pattern. So you can use the full power of flows in Kotlin JS as well. The only limitation, if you had to force me to name one, would be that you can't do run blocking on JavaScript. And that is because JavaScript as a platform is by definition non-blocking. Like it's based on this event loop. So if you're looking for the run blocking block, that's not going to work. Apart from that, it's all good. Like literally all the API surfaces are the same.
Any plans for Vue.js with Kotlin JS?
Yeah, so this is again a bit of an interesting question. We get it a lot actually. Not in the same sense as you could expect it from React, because in React, React just uses JSX, which is kind of this well standardized default thing. Vue.js has it introduces its own compiler, it introduces its own templating language, which makes it a bit harder for us to integrate this. And it's just kind of it's very opinionated in this way. If you wanted to use Kotlin JS together with Vue.js, I would suggest trying the interoperability. So again, you wrap your business logic in a Kotlin framework, you export it to JavaScript. Maybe you make use of the new TypeScript definitions, and then you just write your plain TypeScript or JavaScript Vue.js application, and you interface with your library. It might be quite nice because it actually forces you to then encapsulate things away, and you don't have this tight coupling between UI and business logic.
Right. Does this custom DSL for HTML use PSI file under the hood to generate the HTML file, or is it done differently?
Okay. So we got someone who knows what PSI is. That's exciting. So just for the context for people who don't know what PSI is, that is how we define. I think it's program structure interface, something like this. It's what we use internally for the compiler to look at your kind of the abstract syntax tree of your application. The answer to this is no. It actually just combines these fancy DSL features which we have in Kotlin. So really, if you can command click on all of these tags, and what you'll see is they just kind of call a builder function. So if you're not familiar with how DSLs are usually structured in Kotlin, just Google Kotlin DSL. You'll find a bunch of talks on YouTube, which are like 20 to 30 minutes, which walk you through how you can build something like Kotlin X HTML yourself. Which and you'll see there is no compiler magic involved. It's all just Kotlin code.
Okay. So next question we have is RClass specific to React components only?
Yes, the R stands for React. But as I've shown beforehand, as I've shown on one of the slides, if you just have an external function which you would like to import, instead of saying RClass, you just specify the name of the function, and the compiler is going to accept that as well.
Okay. Okay, so next question is, how does it work under the hood? Does it translate to JS just like TypeScript does?
The answer is yes. That's exactly what happens. We have our own compiler which takes your Kotlin code and gradually lowers it until at the end of the day, there's just pure JavaScript code left.
So next question is, how does JetBrains ensure that with every release of Kotlin, the functionality and compiler support for each platform remains consistent?
That's a great question. I think the answer for that is testing. Yeah, so pretty much we are just, as far as I know, we're just writing unit tests and integration tests for all of these things and making sure that these things are supported. And apart from that, it's just the release cycle. All the platforms, including JVM and native, when a new language feature comes out, they just have to support it, so they support it.
Okay, cool. Is Kotlin JS stable and confident enough to make a simple front-end website?
I mean, there are so many assumptions here to be made, but I know that there are banks, that there are streaming companies, that there are insurance companies which use Kotlin JS either for their internal applications or for some of them even do externally facing applications using Kotlin JS. So judge for yourself. I would just give it a try, but we are committed to Kotlin JS as a platform. It's not going to go away anytime soon, and we're excited for anyone who's going to use it, no matter if it's a simple front-end application or a complex web app.
Are the website made with Kotlin JS responsive?
Well, I mean, ideally, if you do your CSS right, hopefully they are. So Kotlin JS does not impose a limit on how you structure or style your sites.
Okay. Great. So even if we are using KVision or something, so that is also dependent on how we define or design it, right?
Mm-hmm.
Okay, cool.
Yeah.
How will be the performance on different browser like Chrome, Safari, etc.?
So we haven't noticed any particular performance bottlenecks. They again, so for example, with JetBrains Space, we're building this whole integrated suite of tools, and they all run on Kotlin JS. And yeah, I don't think there's particular performance concerns there. If you're doing like number crunching or something, I don't know, if you're trying to do machine learning, that maybe you're gonna get a little bit of an overhead if you're doing it on Kotlin JS. But seeing how most applications these days are I/O bound, as in you're relying a lot on your network connectivity and not so much on your CPU, I don't think you're gonna feel much of a difference. But of course, the answer there is always measure. Like, see how for your personal use case if it makes a difference. Do a reference implementation in both. We try to get as close as possible. And also, there's the big W word called WebAssembly, which it's still in the future. Let's not talk too much about this, but maybe Kotlin's gonna land on that at some point as well.
Yeah. So next question is, any recommended documentation of quick snippets of code where I can easily learn about these components? Like this.
The kotlinlang.org documentation, I would say. If you're just looking for the basic components of the browser APIs, the Mozilla Developer Network, MDN, check that out. They have great resources. They're all essentially just like there you will find everything in JavaScript, but as I said, it's all annotated with types, and the types are going to translate pretty much one-to-one into your Kotlin code. So if you just want to get like an overview of the APIs that are available in total, check that out.
How can I add NPM modules whose only method return a promise? I haven't been able to compile it, and all I find on top is capitalize or camel case example.
Okay, that's a bummer. So my initial expectation would be write your instead of having your function just return a string, as in the camel case example, annotate the return type to be promise of string or whatever it returns. Hopefully that's gonna work. If that doesn't work, very much recommend you join the Kotlin Lang Slack and go to the JavaScript channel and write the snippet you're currently using there, and then either me or one of the team members is gonna have a look at it. We're very happy to help. Yeah, it's just a bit hard to debug over Slido.
Yeah.
So maybe someone can put on the screen or into the chat the link to the Kotlin Lang Slack. It's kotl.in/Slack. Great.
Ask Rishit or anyone other member can please post a link so people can join Slack channels. Yes. So next question is, can I host the website made in Kotlin JS on Firebase, Netlify, etc.?
Yeah, so this is the beauty of actually just compiling to JavaScript code. At the end of the day, if you hit the like distribution button in Gradle, what you get is an HTML file and a JavaScript file. So the answer is you can host Kotlin JS wherever you can host HTML and JavaScript, which means GitHub Pages, Netlify, Heroku, Firebase, like wherever. It's literally like at the point where once you've compiled it, it's no different than any other JavaScript project.
Yeah. So are there any example or GitHub projects showcasing a website or any web page using Kotlin JS and the backend?
If you really want to learn, kind of how this stuff works, I would suggest you go to play.kotlinlang.org, and under the hands-on section there is a full stack application with Kotlin section, which also links to a GitHub account or a GitHub repository, which contains an example app which shows how you can use Kotlin in the back end, Kotlin in the front end, and combine it in a big project. So maybe give that a look.
Kotlin over JavaScript Sounds like a good payoff, but Kotlin over TypeScript doesn't sound all that good, right?
Wow, that's a bit of a loaded question there. I'm gonna say it really depends. I also write a lot of TypeScript, and TypeScript is a fine language. I'm not going to tell you if you're happy with TypeScript, like I'm not going to tell you to change. But if you're looking at it from this kind of multi-platform perspective, if you're looking at, hey, I want to reuse code, I want to reuse knowledge, I don't want to implement the same algorithms in 3 different flavors just to target just to target those 3 platforms, then you might once again consider if Kotlin JS isn't really what you want. And then, of course, for me personally, the one thing that I am not such a big fan of in the JavaScript ecosystem, or in quote unquote vanilla JavaScript, is the lack of the Kotlin standard library. So because the Kotlin standard library, again, I mean, if TypeScript helps you with the static typing, but it's still not going to help you shuffle an array or picking a random element. Like these things I still find are more idiomatic or just more concise when you write them in Kotlin code. But it's at some point, it also depends on where you come from. If you come from the Kotlin side, it might be easier to pick up Kotlin JS. If you come from the JavaScript side, it might be easier to pick up TypeScript. Write a Medium post about it. I would be excited. Like try both of them. Write a post about it. Let us know how we can make Kotlin JS even better. What would convince you? Yeah.
Does Kotlin JS support different levels of style encapsulation, like style that applies only to a particular component, like some CSS specifically to the app?
Mm-hmm. So if you're doing a Kotlin React app, we can actually see the next question on the display already. We have support for styled components, which allow you to do exactly this kind of style encapsulation for particular React components, and also conditional styles, static styles, all these kind of things. So yeah, if you can go nuts with that part. And I'm just gonna take over the next question directly, how to use styled components. I would hope that if you go to the styled components Kotlin wrapper GitHub, so if you look for styled components Kotlin, it's probably gonna be the first result on Google. That should contain a README file, and that README file should hopefully have everything you need. And if it doesn't, go to the Kotlin lang stack, complain, and we're going to fix it.
Okay, sure. Yeah, I have shared that link. Shared that. So, which is better in terms of performance, React.js or Kotlin JS?
That's a bit of comparing apples to oranges, I think. Those things aren't really comparable, but I think there's going to be again, give it a try. I don't think you're gonna be disappointed with Kotlin JS's performance.
How easy it is to make use of hardware acceleration, maybe a GPU? I'm using like TensorFlow.
Exciting stuff. I know. Especially with like WebGL and all these kind of topics. We don't have something to particularly present yet, but I would suggest having a look at the K-Inference project, which you can find on GitHub as well, which is on track to becoming our inference engine, which hopefully will also have multi-platform support at some point in the near to medium future. And then hopefully you can those are going to expose some hardware accelerated parts as well. But generally the answer to that is, if you have a library that exposes it as JavaScript, you can write a wrapper for it, or you can look for a wrapper for it in Kotlin JS, and then you can use it as well.